Hello everyone, welcome to the next video of data structure. Today we'll discuss about quicksort. Now what is quicksort, how we are applying quicksort, everything we'll discuss, and in the next video we'll implement the program of quicksort. But before going to the concept of quicksort, let us understand what is sorting is all about. All of you know that sorting is nothing but it's a process through which unordered collection of elements you are converting to ordered one. For example, in this one, we have taken different types of values like 77, 42, 35. So some random elements are given to us and we are applying some of the any kind of sorting mechanism, and finally we are getting the values in an order which is known as your sorted order. This is the complete basic one that everyone can understand ki why you are applying sorting. Okay, but now coming to quick sort. Now what do you mean by quick sort? Okay, so if you want to check ki how you'll apply quick sort, there are simple mechanism that quick sort is very popular sorting method. And why the name is quicksort? As the name suggests, the fact that in general, quicksort can sort a list of data elements significantly faster than any of the common sorting algorithms. Previously, whatever the sorting mechanism all of you know, and we also know, or whatever the things we have discussed through the videos, but quicksort in general provides the best sorting mechanism, which is the fastest one. Okay, so this algorithm is completely based on the fact that it is faster and easier to sort two small arrays. The best part is what? Now here you are applying two small arrays and you are applying the sorting mechanism. Okay, so definitely this is the keyword, the two small arrays. So how these two smallest arrays are used for the quick sort, that we'll discuss today. Okay, so in quicksort, the basic principle behind this is sort to divide and conquer. Okay, but what do you mean by that divide and conquer? So let us understand through a simple real-time example. Okay, now suppose you are given a large stack of papers. Okay, and what that papers contains? It contains names of the students or names of the employees, whatever. Okay, and you are given a task to sort them by name. Okay, so definitely, as we know something about the principle of dictionary, so definitely we'll sort according to the alphabets. Okay, but what we'll do, instead of considering the entire stack of papers, what we'll do, we'll just divide the entire stack of papers into two halves. Okay, so that means you have to pick a splitting value. That means, for example, L. So that means from A to L, I'll divide one, and then M to Z, I'll divide another one. Okay, so what I have done, I have divided the entire stack of papers into two piles. Okay, one from A to L, second one is from M to Z, and definitely uh, we are not sure whether the both the piles have equal number of papers or not. They may contain equal, they may not contain also equal, but we are dividing. Okay, now the next process what we are doing, from A to L, we are applying the same principle again. Again, you are dividing the sub value into again two piles. That means, for example, suppose A to F and G to L. Clear? Now, the again this A to F, I can divide into A to C, then D to F. Okay, and the division process will go on until the piles are small enough to be easily sorted. Okay, so here again, whatever the principle we have applied to A to L, we can apply to M to Z. Okay, so that means what will happen, ki all the small sorted piles can be stacked one on top of the other to produce an ordered set of papers. Okay, so that means what we have done here, we have given a large problem, we are unable to find the solution for the large problem, so you are dividing the problem into small problems Again, you are dividing into again smaller problems. You are finding the solution of each smaller problem and combining the solutions to find the solution of the large problem. Clear? And this complete strategy is based on a principle of C programming known as your recursion. Okay, so that means in every attempt to sort the stack of papers, the pile is divided, and then the same approach is used to sort each smaller piles whenever there are smaller unit of problems. Okay, so on this particular principle, that how you are dividing the larger problem into smaller problems and then finding the solution of the smaller problem to find the solution of the larger problem is known as your quick sort. Okay. Now, if you'll see the principle, the procedure of quick sort is based on simple thing, that is recursively you are sorting the sub list using a principle known as your divide and conquer. The best approach is divide and conquer. And as for our discussion, we are unable to find the solution to the larger problem. So you are dividing the problem into different sublist, and recursively you are sorting the values by using the principle of divide and conquer. But how you are doing? You are following three different steps. Okay, the first one is you are picking or you are selecting an element. Like in the previous example, we have told that you are selecting L, that this is what my dividing factor, that from A to L one pile and then M to Z another pile. But whenever you are picking out something, that means you are selecting an element to use quick sort. Okay, then what you are doing? You are dividing. Dividing what you are dividing? You are splitting the problems met, and then you are moving the smaller parts to the left and the larger items to the right. And here you are using a keyword known as your pivot. Okay. So what do you mean by pivot and how you are using the pivot element? That we'll see through the example. Okay. But on the basis of the pivot element, you are dividing the entire list into two smaller lists. So for example, if you want to understand what is pivot, now here my L is my pivot element. The selecting element or the element you are selecting, so that the total list you can divide into two halves, that element is known as a pivot element. Okay. And the third part is your repeat and combine. What do you mean by repeat and combine? You are dividing the entire list into smaller unit of problems. Then you are repeating the same steps, and finally you are combining the arrays that have previously been sorted. That means in every step you are sorting one element. Finally, whenever you will get the solution to every smaller part of the problem, you are combining the entire solution into a larger solution. Okay, so definitely we can understand easily by using three steps, simple steps. One, you are selecting the element. Second, you are dividing the elements into smaller units, and finally you are repeating and combining everything. Okay, but this is completely theoretical. Key the principle behind your or the procedure for your quick sort. Okay, so let us understand through an example. So, for example, I have considered some random elements 7, 2, 1, 6, 8, 5, 3, 4. Okay. So, we'll write down the same numbers and we'll do it stepwise. Okay. So, what the elements we have taken? So, we have considered 7, 2, 1, 6, 8, 5, 3, and 4. Okay. Now, as we know that the array index starts from 0, so let us write down the index. Okay. Now, one word we have used, that is your pivot element. So in quicksort, whenever you will encounter this particular word pivot, you will understand we are going to apply quicksort. Okay. So pivot element, which element can be a pivot element? Remember, there are so many confusion with respect to this particular word, but any element can be a pivot element. The first element can be the pivot element. The last element can be the pivot element. The middle element can be the pivot element. Any random element of the array can be treated as a pivot element. Okay. So for our simplicity, what we are doing, we are considering the last element as the pivot element. Okay. And what is the significance of the role of the pivot element? Every element from the beginning before the pivot element will be compared with the pivot element. Okay. For that means from 0th index till 6th index, all the values will be compared with the pivot element. And whenever you will compare, what you will do? Now there are some simple principle. What is that principle? Now, for example, this is, let's consider this is J, and so J is what? J is currently 0. And we will consider one more variable, suppose I, which is my J minus 1. That means I is pointing to the previous position of J. Okay. Now, we are applying a simple principle. To which index J is pointing, that value will be compared with the pivot element. Okay. Now, if the element is greater than the pivot element, we don't need to do anything. Clear? If the element is greater than the pivot element, we don't need to do anything. We'll just increment the value of the J. That means J will point to the next index. But if the value is less than equal to the pivot element, then we have to do some operation. What operation we'll do? Now, let us consider key while J is less than, we'll go till the last one. So here, if we'll consider the size of the array, this is 8. Okay. So that means J will go less than size minus 1. How? This is 8 minus 1 is 7, and J less than 7 means definitely J will come up to 6. Okay. What I'll do, I'll check here. If this array of J is less than equal to the pivot element, what I'll do, I'll increment the I value. I'll swap array of I position value and array of J position value. Okay. And then J plus plus. Okay. So what do you mean by this? Now, if the element is less than to which index J is pointing, if the value is less than equal to the pivot element, I have to do some operation. What operation? I have to increment the value of I, and then I position and J position value will be swapped, and then J index will be incremented. But if this condition is false, that means the index which is J is pointing, the value is not less than equal to pivot, don't do anything. Just increment the J index and point to the next value. Okay. Now, let us understand through this example. Okay. So, in step 1, J is pointing to whom? J is pointing to 0. Okay. J is pointing to 0. So, 7 less than equal to 4. Let us run this one. J is 0. 0 less than 7 is true because we need to target this particular one. 0 less than 7 true. Come inside array of 0. Array of 0 is what? Now 7. What is my pivot element? 4. 7 less than equal to 4. False. False means don't enter to the if block. Go outside, increment the value of J. So the J value will become 1. Okay. So simply I'll remove this value of J. Now J will point to 1. Okay. Again come. So instead of 0, it will become 1. 1 less than 7. True. Come inside. Array of 1. What is my array of 1? Array of 1 is 2. So 2 less than equal to 4 is true. If yes, then I will be incremented. So simply I will now rightly point to 0th index. After that, what do I need to do? Now I need to do the swapping process. Now swap it. So which value will be swapped? Now this I and j position will be swapped. So 2, 7, 1, 6, 8, 5, 3, and 4. Okay? 0, 1, 2, 3, 4, 5, 6, 7. Clear? Now I is pointing to 0. So after doing swapping operation, as per my process, I need to increment j. So previously j as what 1, now j will be at 2. Okay. Again, apply the same principle. Now I need to check currently j is 2, 2 less than 7 is true. Enter to the if block. Array of 2 means 1, 1 less than equal to 4 is true. So again apply the same principle. What I will do? I will increment the value of I. So now I will point to 1 and then I and j position value will be swapped. So after swapping, what will happen? 2, 1, 7, 6, 8, 5, 3, and 4. Okay. 0, 1, 2, 3, 4, 5, 6, 7. It's a good practice to provide the index whenever you are solving the problem of an array. Even if you know that the index is starting from 0, but still you provide the index so that it will be clearly visible to what you are doing. Okay. Now currently I is pointing to 1 and now j will point to 3 because j was pointing to 2 previously. Now again check. J is now 3. 3 less than 7. True. What is array of 3? Array of 3 is 6. 6 less than 4 less than equal to 4. False. Don't enter. Just increment the value of j. Okay. Now if I'll increment the value of j, j will now point to 4. Again check. 4 less than 7. True. Enter. What is array of 4? Array of 4 is 8. 8 less than equal to 4. False. Don't enter to the if block. Increment the value of j only. So now j is pointing to 5. Now come here again. The process you are following. 5 less than 7. True. Again enter. Array of 5 is how much? Now 5. 5 less than equal to 4. False. Don't enter to the if block. Increment the value of j. Now j is pointing to 6. You check it. 6 less than 7. True. Again enter. Once you will enter to the if block, you will find कि array of 6 is what? 3. 3 less than equal to 4. True. True means what we will do? We will increment the value of I by 1 and we will swap the content of I and j position. Okay. Now whenever you will do the swapping process, simply you will draw another array for your understanding and write down 2, 1, then 3, 6, 8, 5, 7, and 4. Okay. Provide the index. Okay. After that, j will be incremented to 7. Now, whenever j will point to 7, 7 less than 7 is false. So that means as per our discussion from the beginning index to the previous position of pivot, all the elements are compared with the pivot element. If any element is greater than pivot, we have not done anything. But whenever there is an element which is less than equal to the pivot element, we have incremented the I index, then swap the value of I and j, and then we are incrementing j. The simple procedure we have followed. Okay. But Once all the comparison is over, now the most important step we'll do, we have to swap array of I plus 1 with my pivot element. Okay. So now this is the turn to swap the content of the pivot element with I plus 1. Now you check what is the index of I currently. So I is pointing to 2. Okay. So I plus 1 means this element will be swapped with the pivot element. Okay. Now once you'll do the swapping, what you will get actually? You will get 2, 1, 3, 4. Okay. Then 8, 5, 7 and 6 after swapping. Okay. 0, 1, 2, 3, 4, 5, 6, 7. Okay. I is pointing to this one. Done. Now what happened actually? One single iteration of the comparison is over, or you can say one round of sorting is over. How will know that? This is the original array what we have taken as input. If you do manually the sorting, so what value actually you will get? You will get 1, then 2, then 3, then 4, then 5, then 6, then 7, then 8. Okay. If we'll provide the index array wise, this will be 0, this will be 1, 2, 3, 4, 5, 6 and 7. That means we are talking about this is an array. If manually will do the sorting, I need to check what is the position of this value 4. The position of this value 4 is 3. That means this is the original position. And you check after doing the swapping, the pivot element has come to its original position. That means 4 got sorted. So one single round of sorting is over and we got one value sorted, that is 4, which was my pivot element. That is what the significance of the pivot element. All elements will be compared with the pivot element and finally the pivot element will go to its current or correct position. Clear? One more significance is what we have discussed, that the quick sort is based on divide and conquer. You have to divide the array into two halves on the basis of the position of the pivot element. That means I'll divide the array into two halves. In the first half, the elements from the beginning before the pivot element will be there. And in the second half, the elements after the pivot element till the last will be there. That means you are not considering the pivot element once again. Why? Because that is already sorted. Okay. Now what you will do? You are dividing the entire problem into some small problems. So you will apply this quick sort to this list 1. You will apply quick sort to list 2. How? You will consider this element as the pivot element. You will consider the sixth element as the pivot element. Okay. So that means the both the small arrays, again you will apply quick sort and again in every step one element will be sorted. Okay. So this is what the principle of your quick sort, that the entire sub problem is given to you. You are applying the principle of quick sort by considering the last element as the pivot element and you are following some process of swapping of the values. Okay. Once you will do swapping, so the array will change. And when the swapping is required, whenever the element which is pointed by j is less than equal to the pivot element. You are just incrementing the value of index I and you are doing the swapping. And finally, you are doing the swapping. You are doing the swapping what? You are doing the swapping of the pivot element. Okay. And if you'll consider and you want to check whether the swapping is correct or not, if you'll check in this particular example, on the basis of the position of the pivot element, all elements in the left hand side will be definitely less than equal to the pivot element, and all the elements of the right hand side of the pivot element will be definitely greater than the pivot element. If this condition is true, that means you will be sure that whatever the process you have followed and the position of the pivot element you have kept, that is correct. Okay. So once again, I am repeating, the elements left side to the pivot element will be definitely less than equal to the pivot element, and the elements in the right hand side of the pivot element are greater than the pivot element. Okay. So this process you are applying, and finally you are doing the partition. What partition? From beginning to the previous position of the pivot element will be in one list. The elements which are after the pivot element till the last will be in another list. Okay. And you are applying again quick sort as per our discussion by considering the pivot element. So if you will follow the same process recursively or repeatedly, finally you will get a sorted array. Okay. So this particular principle is known as your quick sort. And this is very easy to understand. And the process is something like it gives a faster result. Okay. So in this video, we have only discussed regarding the procedure of the quick sort, how the process is being followed by considering the pivot element. And in the next video, what we will do, we will write down the program of this particular sorting mechanism, and we will try to understand the coding part. Okay. So thank you everyone for watching this video.